Hello there, everybody. Welcome back to the Chem Complete channel. I am Professor Tomney, and in today's lecture, we are going to get started with a look at carboxylic acid functional groups. And in particular, as is standard with most functional group learning, we're going to start by learning how to name carboxylic acid compounds using IUPAC nomenclature. So that is coming up on the channel right now. All right, let's get started here, and a quick reminder to head over to chemcomplete.com if you would like to take a look at any of the guides we have for sale to help you with various subjects through organic chemistry. So, for carboxylic acids, there's really two different ways that we approach naming. So the first way that we're going to take a look at is how do we handle open chain compounds, meaning hydrocarbon compounds that contain a carboxylic acid, but they are not enclosed in some sort of a cyclic system. So that's going to have its own set of rules, and then the cyclic system will have its own set of rules, okay? So for open chain compounds, as usual, the first thing we want to do is find the longest carbon chain that contains that given functional group. So in this case, the carboxylic acid. Okay, so I'm just going to draw a relatively simple example over to the right here, and we can utilize this as we're kind of talking about it, and then we'll do some practice towards the end of the video. Okay, so let's go ahead, we'll do, let's make it a 3-carbon. Okay, so here's our carboxylic acid. All right, so the longest chain that contains the carboxylic acid would be this chain right here. Now this is important because some students forget this. The carbon in the carboxylic acid functional group counts as a carbon in the longest chain, okay? So we do not look at the CH2 and consider that to be kind of the terminal or the final carbon in the chain, because this functional group contains a carbonyl similar to aldehyde and ketones and other carbonyl functionalities. When we get ready to name it, we include that carbon from the carbonyl in the naming process for the total carbon count. So because I have a total of 3 here, I know that the basic chain that I'm going to be working with is going to be prop, right? Because that's the prefix for 3 carbons when we do IUPAC naming. So number 2 is determine the numbers for substituents while giving priority, meaning position 1 as far as numbering goes, to the carbonyl. So in other words, no matter how long the compound is, I always place the carbonyl with the carboxylic acid as position number 1 as I am numbering and getting ready to name. So that means that this would be 2 and that this would be position 3. Now in this first example that I have here, there are no other substituents that we have to worry about naming. And it turns out that because carboxylic acids are terminal, similar to aldehydes, meaning they will always end a chain, this hydrogen cannot continue anything further out that way. So because of that, position 1 is already inherent in the naming of a carboxylic acid and its functionality position. So we do not need to state the 1 when we are naming the location of the carboxylic acid. We just state that it's a carboxylic acid, and that's enough. Okay, so to name the compound that we have here, you change the suffix -ane and swap it out for oic acid. So this example right here, if I had to name it, would be propanoic acid. Okay, so it's not propane, it's propanoic acid. And in particular, we're dropping that E there and adding the oic acid on top of it. Okay, so propanoic acid would be the name of this compound. Now, let's go ahead. I'll give you another one that does contain a substituent, and we'll see if you can handle naming it. So let's do, obviously we'll start with the terminal methyl, CH, CH3, CH2, CH2. Okay, so let's take a look at this right here. I want you guys to try to name this compound. So pause the video, do a quick inventory of the carbon count here, the parent chain, all of that stuff, and see if you can name it. Okay, so hopefully you had a chance to do that. This is going to be carbon 1 right here because of the carboxylic acid. So I've got 2, 3, 4, and then it doesn't matter because these are branching in the same way. So we'll just call this 5 here. And that means that overall I'm dealing with a pentanoic acid. Now, if I take a look, in position 4, there is a substituent. It's a methyl group. So if I wanted to properly name this compound, I would refer to this as 4-methyl because I still do my regular naming, and don't forget to alphabetize if you've got more than one substituent. Okay, and then it would be pentanoic acid. And that would be the name of this compound right here. Okay, so switching gears here, we are now going to take a look at how do we handle cyclic compounds. So if I've got a cyclic compound and coming off of that cyclic compound is a carboxylic acid, how do I name that compound? For cyclic compounds, the first thing you need to do is determine the number of substituents while giving priority to position 1 to the carbon that contains the carboxylic acid. So this time, let's go ahead and draw an example of a cyclic compound that is going to contain a carboxylic acid. Okay, so here's the carboxylic acid coming off of the cyclic compound. And then we'll say right down here, we've got another substituent coming off. Okay, so that means that this carbon would be carbon number 1, this would be carbon 2, and this would be carbon 3 right here. So in other words, this carbon is getting priority because it contains the carboxylic acid functionality on that particular carbon in the ring system. Now, the second part is to name the compound as a cyclic system and then add carboxylic acid after the name. So you want to start by almost ignoring the carboxylic acid and just name the rest of the system as if that wasn't there. And then you'll add the name carboxylic acid. You'll literally call it that functional group at the end. So if we take a look here, in position 3, we have an ethyl. So we'll go ahead and we'll start with that and we'll say, I've got 3-ethyl. And then this is a 6-membered ring, so we'd call it a cyclohexane. And that would be the name of the system if it did not have the carboxylic acid there. Okay, but because the carboxylic acid is there, and that's partly why we have this 3 here, we then want to follow up with the second part of the name here and literally say carboxylic acid. And that would be the proper name for this compound here. So what I'm going to do now is I am going to provide some examples and I'll draw these out. I want you to pause the video and see, using the rules that we just went over for naming compounds, can you figure out the name of these structures that we're going to have here? Okay, so let me put this here. We'll give you one cyclic, okay, and let's give you an open chain one as well. So let's make it a little bit longer with some other substituents this time. So we'll do this, and then we'll add another set right here, and then let's make sure we take this out enough. So we'll do this, and this, and we'll end it right here. Okay, so pause the video and see if you can name both of these compounds right here. Give it a pause and then unpause it when you're ready for the walkthrough. Okay, so hopefully you had a chance to do this. If you take a look, this is going to be position 1 for the cyclic system. So if I continue forward, it would be 2, 3, 4 or 2, 3, 4. So either way, it doesn't matter which way around the ring I go, I'm dealing with position 4 there. So when I get ready to name this, I'm going to start with the substituent, which is going to be 4-bromo. It is a 6-membered ring, so I would call it a cyclohexane. And then at the very end of that, I need to make sure that I include the word carboxylic acid in order to let the user know that there is a carboxylic acid present in position 1. Okay, so if I come over here, the numbering starts from the carbonyl that has the carboxylic acid. So this is 1, 2, 3. Now if I go up this way, it would be 4, 5. If I go this way, it would be 4, 5, 6. So you want to go for the longest parent chain, 4, 5, 6, which means in position 2, I'm going to find a methyl group, and in position 3, I'm going to find an ethyl group. So remember, you're alphabetizing this. So it's going to be 3-ethyl to start. Then we'll take care of the methyl, so -2-methyl. And then again, if I do a carbon count, there's 6 total here. So that means that the final portionality of this name should be hexanoic acid. And that is how you name carboxylic acid functional groups. So I hope you found this useful. Leave a like on the video if you found it helpful in any way. If you comment, I'll try to get back to you. And as always, thank you for using ChemComplete for your learning resources and using us as your organic chemistry go-to. You can always visit chemcomplete.com, check out the guides, lots of free resources over there. If you want to support the channel, you can also use the thanks button. Other than that, I don't have anything else here for this particular lecture, so I will see you guys in the next carboxylic acid lecture, where we talk a little bit more about what makes carboxylic acids acidic and what surrounding things can influence their acidity. So I'll see you guys next time.